Okay, hello everyone. I think we can start. I think everything is working. Hello, glad to not see, but at least feel you all here. So my name is Anastasia Kazakova. And I work in JetBrains. So you can find my Twitter and my email if you need to contact me and ask any questions. And today we'll be talking about the C++ ecosystem. And I would like actually to engage all of you to drop any question anytime to the questions pane, because this is not a talk, not a type of the talk where you can learn like about one smart or two smart features from C++ language or about how to use some particular library. No, it's not that type. Here we'll talk about how our current ecosystem looks like, which standards are in use, what's the reasoning behind that, how they're evolving, how the adoption goes with the new standards, what happens with the tooling in the ecosystem. So any questions or comments are very welcome. I will try to follow them and address them while I'm talking. So first of all, a few words about myself. So I was a C++ developer for 9 years. I was doing mostly embedded and networking stuff, working in various companies. And we were launching the 4G LTE network in Russia together with the Yota company. And now I'm with JetBrains and I'm doing product marketing. I'm also doing a C++ user group in St. Petersburg. So if you are anywhere around St. Petersburg, you're very welcome to join as a speaker or just as a guest. And so in JetBrains, I'm responsible for C++ tools as a product marketing manager. So today we'll be talking about these topics. We'll try to cover them all, and hopefully we'll have enough time for that. So let's start. We'll start with the C++ today. Or better start with the C++ yesterday. Like we have in C++, we have macros. So we all know we have them, and we can't avoid them, unfortunately. So we do our best, but we can't. And the issue with the macros, as you probably know, is that this is just a text substitution. So they are not aware of any context. So they're depending on this context. And so what happens here, for example, in this example, so I have this nice macro, and I also have this enumeration defined here. And it includes this text file, which is just txt file. So it's not a C++ file or not any code in any programming language, as you might see. It's just like some lines of text. And what happens when I substitute it, so I finally get the enumeration, and so I can like iterate for this enumeration. I can put a switch case operator here and check some values. And the issue is that I don't know these values because they are actually hidden. So they're hidden by this macro, which is actually defining these values for me. And at the moment when I undefined it, I actually lost any context of where they were coming from. So if my tool is smart enough, it can help me and maybe autocomplete these values. But generally, looking at the code, I don't know what are these values, at least until I go to this txt file and then check this macro. Okay, let's come to C++ today, finally. So if we take a look at this example, I would say that C++ is really good for quizzes. I don't know how you feel about it, but I think that C++ is the best language for any kind of quizzes you would like to run with developers. Here, for example, if you put this code and ask developers what would be the output, that would be a very interesting exercise. So the answer is 1251. And to guess that, you have to like understand the things about passing by reference, the R value and the L value. You have to understand about the multi-character constants, which actually provides us the 5 here for this one. And you can actually add more options here to the list of the overload resolutions set, and get more funny combinations here and get maybe like tons of quizzes like that just in one go. And the problem is that overload resolution on its own is not really complicated. So it's just the basic set of rules which you have to follow to find a proper candidate. But to do it in your head is usually not that simple. So that's some kind of a mind exercise you have to run. Another code is with the overloading functions is one point, but then we can overload operators. And this brings us to the situation when we have this line, when I'm printing something to the output stream, and I have several operators redirecting to the stream. And the thing is that these operators before F1, F2, they are these overloaded operators. So they do something specifically which I provided them to do. And the rest are they're also overloaded in some sense, but they're more or less expected, so some standard overloads. So the thing with the operators overload is that when you look at them, when you look at the operator, you actually never know what it actually does. Is it overloaded? There is probably, you've heard this joke about the C++, that with C++, when you see a plus, actually, you never know, is it plus or is it a minus? These all actually add complexity to the language. And this is some kind of artificial example we came up in JetBrains while testing the C-line tool. And I wanted to put it here just to bring your attention to it, because if you look at it, it looks like kind of a complicated template example. And if we try and simplify it step by step, use another syntax for the variable template, then remove the template completely. So in the end, you can actually simplify the example to just simply return 42. And that's actually everything which this code does. So it just returns 42. And here we come to this particular point that you might write actually quite complicated thing in C++, which will be doing a very simple thing. And there are a lot of people in the community talking about it. If you remember the great talk from Nika Juzitis regarding the initialization in C++, there are also a related talk from Tima Dumler. And just recently at C++ Russia, a couple of weeks ago, we had a very similar talk about the const, writing constant in C++, so how you do that. So the thing is that, as you see, there are different ways of doing the same things, multiple ways of doing just serving one goal. And here we come to this quote from Twitter, which I found a couple of years ago, saying that the problem is not in the fact that the feature is there, but the problem is that if it's there, someone will be using it. And in C++, it brings us to the situation when we have 10 ways of doing one thing. And if you think about it, why it's not a good thing, why it's not a good maybe language in that sense, well, I like C++, I think it's great, but we have quite many ways to do the similar things. And the problem is that it's quite difficult to decide usually why there are so many ways and which one to use. And especially for those who are coming to the language, who are the newcomers. And then it comes to a situation when one person is using one way, another person is using another way. And it brings us to this very weird code where several approaches are used at a time. It looks like someone forgot to use the universal formatting style, because everyone is doing the same using different ways. And this might be a big problem, actually. And I met this quote in the recent book from Google engineers about software engineering Google, which was saying that with the sufficient number of users of an API, it doesn't matter what you promise in the contract. All observable behaviors of your system will be dependent on by somebody. And the same actually applies to the language. So if we have a way of doing one thing in the language, it will be used by someone. And it doesn't matter what are the guidelines, what are the recommendations. So if there are 10 ways of doing the thing, all the 10 ways will be used sooner or later. Okay, so if we look at the C++ language, so why I was talking about the examples and why I wanted to put your attention to them is that many people nowadays are saying that the C++ language is somewhat cognitive overhead. And this quote actually, it was born at the huge thread of discussion when Eric Nibbler posted the great post on his excitement on Rangers coming to the standard. which is a great feature on its own. And he was using the Pythagorean triples example in his blog post. And that actually, particular example, caused some kind of negative feedback from the community, because they were saying that the cognitive overhead and the complexity of the language is too high, and we have to simplify it, not to bring like the complex features to the language. And when we were discussing this with the community once at the JetBrains booth at ACCU conference in Bristol, I've heard from some of the developers that C++ developers must suffer. So like, that's why we have so many ways of doing one thing. But I would say that, like, yes, suffering makes us think better about what we're doing, being more careful and decorate. But maybe we could like have some simpler way of living. And what the people are actually expecting from the language is they want it to be sometimes more naive and more debuggable. And this is as we see it now, this is the general trend, even supported by the standard committee, like to make the language more powerful, but at the same time simpler. Because for many years we were trying to make it more powerful, forgetting about the simplicity part. And the simplicity is probably also important. But let's see if it's that bad, or maybe everything is just fine if we take a look at the language standard adoption. So we'll now talk about some like infographics and some numbers we'll be showing here. So these numbers will be coming from two sources. So one is the C++ Foundation Light Survey. It's run by the C++ Foundation yearly, I guess every April. And the second one is the JetBrains Developer Ecosystem Survey. We also run it yearly, and we did it for 4 times in a row already. And we started usually in the beginning of the year or in the end of January, and run it not for a particular time slot, but until some conditions are fulfilled. I will talk about them a little bit later. So I wanted to highlight some differences between the results and between the surveys that will explain you why some results will be different on the further slides. So C++ Foundation Light Survey is promoted by the C++ Foundation, and it's definitely the goal and the effort of the language committee to understand the language and how it's used better. And this is really great effort, because when you work on a language, you definitely want to understand how it's adopted and what tools are in use to improve the language further. It's run in English language only, and in that sense, it's a little bit biased to the English-speaking audience. So because it doesn't cover those audiences which are not speaking English very well, like Chinese or Indian audiences. So also, when we are analyzing the results of the survey, we feel that there is some bias to this C++ Foundation survey in terms of the professional level of the developers. And we'll see it a little bit later. JetBrains Developer Ecosystem Survey, we started it in 2017, and we translated into 9 languages. So it's like English, Chinese, Japanese, Korean, Spanish, and Portuguese, Turkish, and something else I don't remember right now. So, and the goal is that we know that the 70% of all developers across the world are actually gathered in 18 countries and are covered by this set of 9 languages we do translate our survey to. So the goal for us is to cover this majority of the developers in these countries and speaking these languages, to be sure that we are not biased to some particular country or some particular language or some particular part of the world. So, and we run this survey actually not for a particular time slot, but until we get enough answers from these countries. And then we apply the weighting to the data, and the weighting it's there because we know how what's the ratio between the professional developers and the students in every country, and we try to balance the responses we get from every particular country to reflect this balance, so that we're not, for example, biased by some big number of students from one particular country. So if we talk about the number of answers we collected, so for C++ Foundation Light Survey this year, 2020, they collected a bit more than 1,000 answers from C++ developers. For JetBrains Developer Ecosystem, so in total, we collected like 44,000 of answers, but then we remove all the answers coming from the internal channels, and these channels are mostly our customers. So we remove this to not to get the data biased by our tools, by our customers. So we collect them separately. So the infographics is built on top of the data collected from the external channels and external promotion. And this is 19,000 respondents for all languages. So the JetBrains developer ecosystem actually covers not just C++, but all the technologies and all the languages. And so it's 19,000. And so for C++, it's nearly 2,000. So it's 1,800 of C++ respondents. So yeah, and as I said, it's the weighted data, and we actually publish all the data along with the raw data. The infographics is already published for this year. The raw data will be published a little bit later, and you can also find the description of the methodology and how we weight the data there. So if you would like to repeat the experiment and check the numbers. So when I said that the developer ecosystem survey audience and the audience of the C++ Foundation Light survey are slightly different, I was meaning this. So if you look at these charts, this is how many years of experience people have in general in programming following the developer ecosystem survey here and the C++ Foundation Light survey here. And you can see that for C++ Foundation, actually this is 66%, it's 10 plus years. So the audience here are the professionals with more than 10 years of programming experience. And for developer ecosystem survey JetBrains, this audience of 10 plus years of experience is just 18%. So we are more balanced in terms of the years of experience. So we have lots of people with like less than 1 year or 1 or 2 years of experience. And this actually affects the results in some parts of the infographics. So, and also we've checked if we slice this to C++ in particular, so like for example for C++ Foundation, it will be 56% of the developers with 10 plus years of C++ experience, which is actually great. I mean, that means that the foundation survey is mostly filled by the people with a very huge expertise in C++. So if we take the developer ecosystem survey, so if we try to understand the audience who are filling the survey, these are mostly fully employed, the developers fully employed, and also we have many students, working students for C++. And now let's look at the numbers. So one of the maybe most useful and interesting chat here is how the C++ standards are doing in 2020. So, and these are actually the distribution. So I'm really glad to see that here is the C++ 20 with 12%. And here is C++ 17 with 41%. And this is actually a great result. So when we were starting our C++ tools back in 2013, 2014, we also did some kind of research. It was very naive at the time. We we were not that good at making the proper research and asking the proper questions, because you know that the success of every research is the proper question to be asked. So that time we were kind of doing some silly mistakes, but still we managed to collect some good data. And this data showed us, surprisingly, nearly the same numbers for C++ 98 and 03. It was nearly the same, 14%. And for C++ 11, at that time, it was 44%, which is now 46%. So there is actually an interesting side question you might ask here, which is about how many C++ developers are there in the world. I don't know if anyone actually asked this question or was wondering or was trying to find out or to search for these numbers. They're not that publicly available, so we do calculate them in JetBrains for sure, because we're very much interested in that. So in 2014, we estimated the number of C++ developers as 4.4 million. And in last year, we estimated it as 5.4 million. And this is the general C++ developers numbers, and 3.6 million for just the professional developers. So this is not counting students or self-employed developers. So, and as you see from these, like if we take, for example, 3.6 million professional C++ developers, 12% will be already using C++20. And this is great because this is the year 2020. The standard is coming this year officially, and 12% are already on C++20. And so we for sure compared how it did the previous year, but before we move to that, I wanted to compare also the very similar question from the C++ Foundation Live survey, but it's not fully similar. Like the C++ Foundation, they asked the question about the standard in slightly different manner. They asked what are the features which are allowed from the particular standard. And here is that pretty much all the features from C++20 are allowed even for a bigger number of C++ developers. That's actually 22%. This is much bigger than our 12% in the developer ecosystem survey. So if we compare with the previous year, so I actually can't put here the 2020 standard because like there were no 2020 in the previous surveys, and we also were counting C++98 and C++3 separately, which we don't do for now because probably this is the more correct way to join them in one answer. But anyway, so if you take a look, so you can see that the C++17 was growing every year. So it also started from 12, then 18, then 28, and if we go back to the current year, it's 41. So it's the significant growth, I would say. So quite many people are on C++17 these days. And this is great. Like C++11, the standard, which was like the big renaissance in C++ language and which moved people back to C++ from many maybe other areas. So it's kind of decreasing, but it's still, if you take a look at this year, it's still 46%. So it's still quite many. It's still a dominating standard if we compare all of them. So C++98, C++03 are slightly decreasing, but still holding their positions quite strong. So, but I think there are reasons for that. There are areas which are moving very slowly. We'll talk a little bit later about them. So we also ask people about if they plan to migrate to the new standards. So it's good to see that nearly like even more than half of the respondents, they are planning to migrate to a new standard in the next year. And you can see from which standard the people are planning to migrate to which one. So obviously, if you're closer to like C++20, it's easier for you to move there. But it's good to see that these 8% who are actually planning to move to C++20 from C++98 are free. These are actually great people who are moving from quite an old C++ standard to a very new one. So if we take a look at the C++ Foundation Lite survey, in the survey, they ask about the major pain points that people experience with the language. So we were talking about language complexity, about all these overheads, and about all these things of like all these aspects of having 10 ways of doing one thing. And what are the main major pain points for C++ developers in 2020? And surprisingly, like moving to the existing code to the newest standard, it's not the top one reason in this list of major pain points. It's just 7% following the C++ Foundation Lite survey. However, if you take a look at the top 3 reasons, which are managing libraries, build time, and setting up a CI pipeline, you could actually understand that while this is not mentioned in the C++ standards directly, still this is very connected thing. So this is very, I think, very related to moving to a new standard upgrading. So what are the risks when you are moving to a new standard and how you can actually overcome these risks? So if we are moving to a new standard, so first of all, we all are like while developing, we all are using various libraries and SDKs. And so if these libraries and SDKs are not moving to a new standard, then we can't move either. So, and this is what happens to the game developers quite often. So when they are planning to move to a new standard, their compilers is not ready, which is the second point, or if their SDK for the targeted console like PS4 or Xbox, if they're not ready for a new standard, they can't move because they still have to target these devices with their games. So also like libraries and SDKs, the compiler. So like the compiler support is not yet there for C++20 fully, but I would say that the compilers are doing a very good job this time. So they are approaching quite fast. So the other tooling support might be missing, like the IDEs, the static analyzers, whatever. So whatever tooling you are using, if it's not there for the newest standard, you probably won't be moving. You probably will be waiting for your tooling to approach these new standards. If everything works fine, you probably will try to move, but you might run into the situation when your code doesn't compile, or it does compile, but it does work differently, which is even more trickier to debug. And the last point here is that developers actually usually have lower expertise within your standards, so you have to spend some resources of your team, of your company, to educate developers on the newest standards. So these are the risks everyone have to take into account when they are moving to new standards. So how you can actually overcome these risks and these difficulties? There are several ways. And the first one is for sure unit testing. And there was a very good talk from David Sankel at CppOnSea in 2016 about the unit, not about the unit testing, but about the building software capital. And there was a part about the unit testing. And I really like his part of the talk when he was talking about like 100 reasons people are not writing unit tests. So what they usually say is that this is the UI code, or this is the code this code actually depends on some resources like these core networks, so I can't unit test it. Or I already know the code is correct, and the most popular reason is that I needed actually to ship this code yesterday, so I can't do the unit testing right now. Not a good timing. So, and like for sure this is just not the true reasons. Like you can overcome every point here, like extracting the logic from the GUI code. You can like use some simulators for your resources, and you can like put a strict process for your unit testing in the company. So to put it, for example, ahead of the code reviews and ahead of other things, so that the unit tests have to be there. So if we take a look at the unit tests and how the people are actually using them. So we asked in our survey, so if the people are doing the unit testing for C++ code and which frameworks they're using. So, and you see that 44% of the respondents, so quite many, are not using any unit tests at all. I really do hope that they have something instead of the unit tests, like some validation or some certification or something, because otherwise it's quite a sad number here. So 15% are not using any particular framework, but still doing the unit tests. So probably they're using something in-house or some other way of testing the code. But like the top three here is, it stays the same for several years. It's Google Test, Catch, and Boost Test. So Google Test is actually the leader here. Very popular framework, but I would say that it's this year is decreasing because all the people are now, all developers are more fan of the header-only framework, which Google Test is not. But it's still very powerful and very popular on many projects. Catch is approaching really fast, and I would like to congratulate Phil with the great progress here. Like 14% for Catch is great growth from the last year. Boost Test is kind of decreasing, maybe again because the partially it's maybe decreasing because of some like Boost issues themselves, or maybe because like to use it in the header-only manner is not possible on a real code, because if you like include the Boost test as a header-only library, the compilation time increases dramatically. So people are mostly not using it this way. And if we speak about the header-only frameworks, here's the doc test, which is growing. It's now 3%, but it's growing quite fast, I would say. So it just started recently. So it's a new framework created by Viktor Kirillov. And if you're interested in it, you can check his talk from CppOnSea, where he's explaining all the benefits of the doc test. So there are some other framework which I didn't put, which are less than 1%. So I just skipped them not to use the space on the slide. The second thing is the static analysis. So one way to check that your code is not broken after you moved it to the new standard is unit testing. The other way is the static analysis. And we had at my user group in St. Petersburg, we once had a talk on static analysis, and we had a very good discussion with the audience about how they feel about the static analysis and at which points, at which steps of their workflow they would prefer to have it. So, and I was surprised quite many people voted for not running static analysis at all. There was an audience for the answer like running the static analysis manually from time to time. And quite many voted for running it weekly, but on the CI server, like Friday evenings. So the workflow would probably look like running the static analysis on CI on Friday evening and checking the results on Monday morning, which is maybe not a good thing to do because you'll completely forget about what you were doing on the previous week to fix the issues. And to me, like, the closer you're to the issue, the easier it is to fix it. So when you run the static analysis in the background, in your tool, in your IDE, this actually captures the issues right when you're on them, which is probably easier to fix. But it was interesting to see how the different people feel about the static analysis. So the data which we collected in the developer ecosystem survey is this. So as you can see, again, quite many, 45% said that they are not using any static analysis at all at their C++ projects. But another 46% actually said that they're using tools built into their IDE, which made us feel responsible for the quality of the code of the C++ developers, because if you don't don't integrate the proper static analysis tool, probably the people won't be using it, and it might be good for them to use it. So but nowadays, the tools are actually bundling at least Clang family tools. So it's the typical situation when the IDE has some tools built in. So the Clang family is actually quite popular, but there is some aspects here you have to take into account. So Clang tidy, as you see, like 23%. So the story with the Clang tidy is this is the whole bunch of checks, and these checks are committed to the Clang tidy. So you can implement your own check and actually try to commit it to the repository. So there are so many checks, and some of these checks are very specific to like some particular companies. Like there are a bunch of checks from Google company, for example, and some others. So probably you don't need all of them. And so there are like two opposite strategies on how to use Clang tidy and a few in between. So these two opposite strategies are, like, we call it asterisk and minus asterisk, which means like turn everything on, which means put an asterisk to the run command, to the settings, and then remove the unnecessary checks one by one. The problem here is that probably when a new check appears, you will see it, you will get it working on your code, but because of that, you might get quite a lot of noise when the Clang tidy is updated when you're updated to a newer version. And the opposite strategy is minus asterisk, which means turn everything off and then add the checks one by one. And here is quite the opposite problem. So because you might miss the checks when they are appearing in the Clang tidy when you are upgraded, for example. So there are a few strategies in between, and that's what people usually try to do, is when they try to turn on and off some particular groups of checks. And this is probably the best scenario here, how to behave with the Clang tidy. So, but it's kind of difficult to understand which group of checks you actually need in advance and turn them on and off sometimes accurately. So it's always a question of if you turn on too much or too little. So there are other static analysis tools here as well, and there are those which didn't fit into the infographics, like PVS Studio is also there, and some others. So I just skip them. So if we come back to the major pain points list here, so you would see like the first one is the managing libraries. And yeah, so we're in C++, and for many, many years, many decades, we're not having the de facto package dependency manager, the standard one. So we have several which are now growing quite fast, and which is actually great to see them, like Conan or VC package. And there's also like these things like B2 and some others. So, but nearly half of the respondents answered that they're not using any dependency manager tool, and 23% are relying on a system one, like the one provided by their operation system. But Conan and VC package are growing here. So, and it's very interesting actually to see here. So, VC package is 8% in developer ecosystem by JetBrains, and Conan is 6%. And if we take a look at the, this is from the numbers from the C++ Foundation Light survey, we can see that there's nearly 14%. So probably the audience of the C++ Foundation Light survey, which, as you remember, are more developers with the bigger experience in programming in general and in C++ in particular, they're using the dependency management tools more often. Okay, and now, of course, the project models. So when you're creating your standard, it still starts with the providing the proper standard to your build system, to your project model. And this is the situation about the project models in C++. So we don't have a standard one. We have 14 creating the 15 every time we try to create a universal one. So we asked about the project model popularities in the developer ecosystem, and I also brought here the results of the C++ Foundation Light survey to compare, because there are some interesting comparison here. So CMake, VS Projects, MS Build, and Makefiles are definitely the top 3, and this top is quite constant. With only exception that CMake actually was not on top maybe 3 years ago, so it was Microsoft format, the MS Build, but the CMake was growing so fast that it actually overgrew the VS project, and now still keeps this growth. And I would say that I was really surprised to see that in C++ Foundation it's like 78%. So it's the majority of those who filled the survey, they were using the CMake project model. So in developer ecosystem by JetBrains is 53, still quite many, but a little bit more balanced with the others. So, but the top 3 is kind of reasonable. So because we'll talk in a minute about various areas where the C++ is used. And so in game development, the MS Build, the VS project is widely used because it's all about like Windows development, and Makefiles are widely spread in various embedded sectors and so on. So yeah, and if we take a look at the major pain point list from the C++ Foundation Light survey again, I really like this list. It shows how the community feels about the language, and you can see these 3 things going one by one in a row there, like managing CMake project, managing Makefiles, and managing MS Build. There is a question, by the way, about the test coverage. So did the surveys provide any insight into how respondents measured their test coverage? I don't think we don't have it in developer ecosystem survey, but we were planning to add it maybe for the next year because we're kind of interested in that. And I don't think that the Foundation Light survey has something like that. But we can share the idea with Herb Sarter. Maybe he could add this question for the next year as well. For now, I don't think anyone is collecting this data. So yeah, let's go briefly through the areas where the C++ is actually used widely and try to understand how the language is used there and what are the particular tools popular there and language standards. So definitely when we talk about the C++, the major areas where the C++ is kind of dominating is the financial area, the trading, the embedded systems, and the game development. There are also like machine learning, networking, and others growing as well. But these first 3 are the top 3 areas. So let's look at them one by one very briefly. So I won't dive deep into them. There are lots of interesting talks around these areas, and I will show you a few links and will navigate you to a few good talks from CppCon, for example, about each areas in particular. So when we take a look at the financial area about the HFT, about the trading, so the C++ there is for all types of calculations. So there's also other languages like Java, C# for the front end, Python for scripting, but C++ is there for calculations, and the major reason there is the low latency. And the low latency is actually means, so it's not about the average and it's not about the throughput. It's exactly about the low latency, because when you are successful in your trading calculations, like 4 out of 5 times, but you lose in 1 out of 5, then you lose finally. So you have to be successful 5 out of 4 times. Like these people, for those who are working in the financial areas, they're all the time they're caring about the price prediction things, about how they allocate the objects. Like, for example, they're using the pools of the pre-allocated objects instead of like reusing these objects instead of allocating them, which is kind of like an obvious thing for them to do. And it's actually interesting to see that if we compare, like, the blue numbers here, the blue charts here are the general numbers, and the green ones are the financial slices. So we do slice all our data in which we collect in the developer ecosystem survey by these three areas: financial, embedded, and game dev, and collect these numbers so we can compare actually how these particular areas are doing in comparison to the general. So, and you can see that the C++20 is actually even more popular for financial area than in general. So, which is very interesting to see. And in terms of the unit testing, it's also interesting to see that like some particular frameworks, the top 3 frameworks, are actually more popular for financial area than in comparison to the general. So these people are more reliant on the unit testing with the widely used frameworks. Before we move forward, let me check the question. So there is a question like on slide 33, summon percentage go above 100. Yeah, so this is the quite often situation with developer ecosystem data. So we usually provide the questions with multiple choices so the people can select several answers. So it's obvious that the sum or the percentage could go above 100. This is how it goes. And yes, following the second deferred question, like, yeah, 30% of those who are doing the financial development stated that they're not running the unit test. I would expect them actually to run some certification or something, because otherwise it would be very interesting to know how they deal with all the things in the financial area. But yeah, these are the numbers we collected. I'm also actually very surprised every year when I see lots of people who are electing that they are not doing unit test at all. We were actually introducing this no framework option exactly because we were considering that maybe the people who are selecting these no tests, they are just not using any particular framework. So we introduced a separate option for that. But again, we still have quite many people who are selecting that they're not doing unit testing for their C++ development at all. So now let's go into embedded. So embedded world is really controlled by the hardware vendors. So they provide the hardware, they provide the compilers, the starter kits, the SDKs. And so everything, when you want to move to a new standard, you actually rely on them completely, because you want your like starter kit or your environment or your compiler, you need to move to a new standard. But this area is also like covered by many standard compliances, many certification tools. So they have lots of things like that. They also are known for doing more the C structs with function pointers, the C++, and so widely using the address arithmetics. But they are moving to C++ right now, and there are lots of talks around that about how you should do C++, proper C++ in the embedded area instead of old style C. And there are some interesting things there in terms of the C++, like they have some very special memory structure, usually packing the data, so to be able to fit it into the hardware. So some compile time optimizations or some compile time activity is actually not possible for them there because the compiler not always know how the data is actually located in memory, so can't cast it correctly. So there are lots of interesting things happening in that sense, and it's kind of natural that we see the older C++ standards more popular in that area. But again, there are lot of people in the community nowadays talking about applying new C++ standards and modern C++ standards to the embedded area. So if we take a look at the numbers, so we can see how the general numbers are compared to the embedded. So as I said, the older standards are more popular. So you can see the 18% for C++ 9803, and you can see 47 for C++ 11. But still, there are quite many, like 11 on C++ 20, which is like not that bad, I would say. The thing that I don't have the data, but like we collected the data regarding the unit testing usages in embedded, and it was not really encouraging at all, because they also have quite many people who are not using unit tests, and I really do hope that there is some certification test instead, or something else they are using instead of the unit testing. Now let's go to games. So the game development is very Windows specific. So if you take a look at the AAA games, they're mostly developed in Windows, and the AAA games are mostly C++. So the if you in general take the world of AAA games, there is like Unity games, there are Unreal Engine games, and there are custom C++ engines, and the rendering is done usually in pure C. And there is like these SDKs for consoles, which, as I said, you have to upgrade to a new standard if you would like to move to a new standard in your game code. And the interesting thing is that this is the area which actually needs new standard a lot, in terms of that they are really waiting for the reflection in the language. So we still don't have it in C++. So not sure when it's exactly going to come. Big hopes for the maybe next 6 years. So every game engine actually is using something instead, so simulating somehow the reflection mechanisms. So, and if you take a look, for example, the Unreal Engine, they are simulating the reflection mechanism via macros. So reflection in game development, if you don't know, so it's usually used for not only the serialization, but also for adding some characteristics to the game characters and so on. So these game developers are often using some custom allocators, which they want to be the part of the type. So they're usually not happy with the allocators in the standard library. And you probably know that there is the Electronic Arts standard library, which were pushed to become some kind of a standard for games. I don't think it's there, but it's still very popular for standard library for game development. And there are very interesting things about how they do the memory management. There were a couple of talks at CppCon when the people from Ubisoft and other companies were explaining how they allocate, how they make these arrays of standard size, how they make these objects of the lifetime equal to the frame, and so on and so forth. So, and yeah, when I was talking about the reflection and macros, so you can try to forget about the macros in the C++ language, but when you come to Unreal Engine, game engine, for example, you will see this U class, U property, U function, and so on, which are exactly the macros emulating the reflection mechanisms. So, and these are very, actually, I would say creepy macros, because they have len macro inside, so it usually breaks the IDE. I mean, the highlighting if you try to do it properly. So you have to overcome this somehow, make some workaround around that. So if we take a look at the numbers, so C++ 17 actually surprisingly very popular in games. So it's like 51%. It's great. And the C++ 20, again, it's higher than the general numbers. So it's 60%. So in general, I would say that the game development is closer to the newest standard than the the average C++ developer. So as you see in these three areas, if we take a look at how they use the standards, you would notice that like financial and game developers, they are closer to the modern standards because probably they are expecting more things from the language. And I know that these people are very active in the committee and they care about the general principle of the C++, which is like don't pay for what you don't use, because it's very important for the areas. Embedded is kind of a little bit on the older standard side, but still they're moving forward, and there is some activity in the community which and people who are trying to move them to the new standard. So, and in the end, I wanted to talk a little bit about where we are now with in 2020 and how the general we might feel about the language. So if you look at how the language evolves, so this C++20, it's probably like everyone have big hopes for it. Everyone hope that it will be the next big standard after C++11, because it has that many great things inside, like concepts, like modulus, like coroutines. But the problem is that it still requires lots of work because, for example, we have models, but we don't have a modular standard library. We have coroutines, but we don't have coroutine supporting types in the standard library again. So, and we're still missing the contracts, the reflection, the pattern matching, all the things that are going to come to the next C++23 and the others, the next standards. And there is this very interesting paper about the overall plan for C++23, which you might be interested in, just to check and to see how the language is going to evolve in the next 3 or 6 years, maybe. And just to wrap up, I would like to summarize some points which I often hear about the language, and I just got some kind of confirmation of that these questions are very important to the C++ developers. At C++ Russia conference a couple of weeks ago, we were doing an interview with Herb Sutter and Bjarne Strastrup, and we were collecting the questions from the community, and we were asking what is actually important to the community, what they want to ask Herb and Bjarne. And we've got many repetitive questions, and quite many of them were like the top three is probably collected here. So like developers are constantly asking the people like Herb or Bjarne or other people from the committee to compare the C++ to like Rust, Go, or D and other languages. And they usually ask like, how do you feel about language if we're doing good in comparison to others? It's actually a very good thing, because that means that C++ developers are looking around them and trying to see if we could borrow some good things and learn some good experiences from other languages. But it's interesting to see that being like that, not an old language, I would say, but a language with a long history, we're still actively looking at others. It's funny to see that C++ developers often discuss what they would remove from the language. I think if you ask like any group of C++ developers what they would remove, you will get lots of interesting answers. And I've heard many various options here, like from various ways of initialization to macros and like other things. And the third point is usually not a question, but like just the statement that the complexity sometimes looks scary when you look at the new standards. Sometimes indeed it's kind of scary, because if you're not very well educated about like the previous standard, looking at the new one, you might feel that you're losing the points and you're like not understanding how the language evolves. And this is actually what we probably have to address with the whole community, like trying to educate people and to help them with the new features so that they're not looking scary to everyone. And there is this paper from Bjarne about like thriving in a crowded and changing world of like C++ from 2006 to 2020, where he overviews how the language evolves and answers many questions regarding like how the C++ is still doing and if it's going to be retired or if it's still a very active language. So if you're interested in any of this question, I would encourage you to check this paper, download it, and try and read it, but be aware it's very long. let me just wrap up with the final slides. So nothing was destroyed when I was preparing with this talk, but this is just the number of coffee capsules I destroyed while cooking the talk. So, and I will try to answer some questions I see in the chat. So finance and game dev are very active in the CPP committees. Yeah, that's true. It's indeed explaining why they're also more keen to use the latest standards. In what extent this could be biased in the direction taken by C++. I would say like that's true that the financial areas, financial developers and the game developers, they are very active in the C++ committee, and they know what they need from the language and the worker need, and they definitely like biasing the language in that sense. But that's good because these are the top 2 out of 3 top areas for C++. So who would actively like who would actually who would like to actually put more efforts to the language? Those who are not using it actively, some small areas, or those who are using it as a top 3 areas. Definitely financial and game developers, they are very interested in the language, and I feel personally that it's good that they are biasing the language in some sense. Maybe it would be good if embedded developers also join them, and all these areas where C++ is kind of popular. I mean, like that. In that sense, the language will be practically useful. So in other words, why is the embedded community not following that trends? I would say that like I was working in the embedded development for 5 years, and I would say that the problem is that many embedded developers are still on C. So they are still on C with structs and function pointers. They don't care about the modern C++ features. And somehow it's not because they don't like the modern language, but maybe because when you take, for example, some official description for some hardware board, quite often what you get is the like 40 or 50 lists of macros describing the registries you will be working with and other hardware stuff. So, and you start with this vision from scratch, not the C++, and that's the problem. So this is how the vendors pushes you in some way to use these old style things in the language. So, but I know that there are quite many consultants and trainers and people in the community who are trying to push the embedded developers to a modern language. And there are lots of interesting content. For example, the Meeting C++ conference, they now have this like the day of the embedded, Meeting Embedded, when they discuss exactly how the language evolves for the embedded community. And I think it's very interesting to see and check the talks there exactly in terms of if these people are going to be active in terms of the C++ language. Hope that somehow answers the question. So there are no more questions. I will be waiting for some time for them. So and here are actually the links you might find useful. So for the C++ Foundation Developer Lite survey and to the Developer Ecosystem survey, and this is for 2020. But you can like check the links and go back for previous years. And also like there are a few talks I was mentioning here, like there is some Herbstadter talks on which is first on more powerful in C++, and there is these talks about how the game developers are doing in C++, like C++ in huge AAA games, memory and C++ debugging at Electronic Arts, and you can check the Electronic Arts standard library as well. And the Carl Cook's talk on trading systems in C++ is also very useful if you would like to learn about how the C++ is used in financial sector. So these are the useful references you might check, and I don't see any other questions. So you can actually ping me anytime in Twitter or email if you have more questions on the data or on the numbers. Thank you.